The first thing that we're going to look at is how to make a factor tree. In other words, we're finding the prime factorization of a number like 468. Hopefully we remember that a factor tree normally starts with a prime number, and it starts with 2 if your number is divisible by 2. So 2 goes into 468 234 times. From there, 2 goes in again, 2 goes in 117 times. From there, since 2 no longer goes in, we try 3, which 3 does go in 39 times. Again, 3 goes in 13 times, and 13 is a prime number, so we know that we are done. So this is 2 times 2 times 3 times 3 times 13, or 2 squared times 3 squared times 13. This becomes the prime factorization of 468. Now let's look how we can use that to find GCF, or greatest common factor, and LCM, or least common multiple, of these two terms. One thing you can do is you can make a factor tree for any of these numbers. So I'm going to make one for 12, and I'm going to make one for 8. So for 12, we have 2 times 2 times 3. For 8, we have 2 times 2 times 2. If we're looking for the greatest common factor, we're looking for what their prime factorizations have in common. Their prime factorizations have in common 2 factors of 2, or the number 4. For the variables, as far as GCF goes, if you think about x squared is x times x, compared to x to the first, which is just x. What do they have in common? Well, they have a factor of x in common. And then look at your z's. Z, 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 compared to z, 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 z. They have 3 factors of z in common. And since this is the only one with a y, it can't be in common because this one does not have anything. So your GCF of 12x squared z to the third with 8xyz to the fourth is going to be 4xz cubed. Let's look at the next one. We have 16, which is 2 and 8, 2 and 4, 2 and 2. So we're going to have 2 times 2 times 2 times 2 compared to 4, which is just 2 times 2. Their GCF is going to be 2 factors of 2, or 4. As we look at the variables, this one's a little bit easier because there's no exponents. They share 1 factor of x and 1 factor of y. So we're going to have 4xy. Now let's look at this last one, 10 and 25BH. So 10 is 2 and 5, 25 is 5 and 5. So what's their GCF? Their GCF is a factor of 5. What variables do they share? They don't share any. So your GCF here would just be 5. Now let's go back and talk LCM. LCM isn't as important in this chapter, but it's still something that you should know. Least common multiple normally means it's getting higher. GCF is typically lower. Least common multiple is typically higher because it's a multiple. To find the least common multiple using these factor trees, you would take your GCF times the factors that are left over. In this case, a factor of 3 and a factor of 2 are left over. So our LCM is going to be 4 times 2 times 3. In other words, 24. Now, if you can do this by just looking at the numbers, go for it. You do not have to make these factor trees. But for some numbers that you're not quite familiar with the factors, it might make it easier for you to use the factor trees. Now, as far as the variables go, for an LCM, because it's a multiple, you're picking the variables with the higher power. So in this case, we're going to have an x squared because we can multiply this by x to get to x squared. Therefore, x squared is a multiple of x squared and x. Same thing with the y. We're going to have a y here because we can multiply this by y so that they match, thereby making y a multiple of y. The z's are the same thing. We have z to the third compared to z to the fourth. Z to the fourth is going to be a multiple of z to the third because we can multiply it by z to make it z to the fourth. For this one, same thing, GCF of 4 times the remaining factors, in this case 2 and 2, because this one doesn't have any. We find that our LCM is 16. 4 times 2 is 8, times 2 is 16. And again, with the variables, you pick the one with the highest power, which in this case is just going to be x to the first, y to the first, and z to the first. So I'm hoping this last one is fairly simple. GCF times the unused factors would give us an LCM of 50. You pick the variables with the highest power, the b and the h. So I just want you to kind of take a look and watch as I simplify this. 4 times x plus 6 would be 4x plus 24. 2x times 3x squared minus 8 would be 6x cubed minus 16x. Negative x squared y times y squared would give me negative x squared y cubed. That same term times negative 3x would give me positive 3x cubed y. What do you notice about these two terms compared to this? These two terms compared to this, and these two terms compared to this. I'm hoping that you realize that this number in front of these parentheses, I know the negative's a little wonky, but is the GCF of these two terms. We are going to be using the GCF as a method of what's called factoring. It's something you always look for first, and it can be done using, any number of terms. So this particular method can be done using any number of terms. And here's how you do it. You look at your two terms and you figure out what the GCF is. Again, if you want to use the factor tree, you're more than welcome to. So 12 would be 2 and 6 and then 2 and 3. 16 would be 2 and 8, 2 and 4, 2 and 2. So what do they have in common? Well, 2, 2, 2, 2. They have two 2's in common, which means a GCF of 4. Now look at your variables. The greatest common factor for the variables would be x, so you pull it out front. Now we're going to open up our parenthesis, and we're essentially going to undistribute the 4x. Or you can kind of think about it as dividing it away from each term. So if you divide it away from the 12x, you'd be left with 3. If you divide it away from the 16xy, you'd be left with 4y. So I just want you to kind of look at what we've done. What kind of problem was this in the beginning? This was an addition problem. How is it currently written? Well, it's currently written as multiplication. So we were able to change an addition problem into a multiplication problem. And that's going to become very important, our ability to change from addition and subtraction to multiplication. So you're going to do the same thing here. You can make a factor tree if you want. You do not have to if you already know what it is. But again, it's something that might help. If you come across numbers that you're just not sure of, you can always fall back on making a factor tree. So in this case, we have 3 2's in common, or a GCF of 8. As we look at our variables, we have the variable a, b in common. And again, we're going to think about this as kind of dividing it away. What would you be left with? Well, if we take 8 away from the 24, we'd be left with a 3. If we take a away from a squared, we'd be left with a, and the b's will cancel. For your second term, we'd be left with 5 and nothing else. The variables are on the outside here already. So we've now changed this to multiplication. It works the same way with 3 terms. I know this one isn't in your notes packet, but I just kind of put it down here. As I'm looking at the numbers, my GCF is 5, then a, b. Since this one's a to the first and this one's b to the first, those are our smallest variables. Those are the ones that become part of our GCF. And then it works exactly the same way. If you factor 5ab from 10a cubed b squared, you're left with 2a squared b. For your second term, you'd be left with 3a minus 1, because we're going to factor out the 5, b squared. And again, you're done. You've taken this from an addition and subtraction problem and turned it into a multiplication problem.